In this problem, I need to graph the logarithmic function f of x is log to the base 1/2 of the quantity x plus 3 minus 2. So the first thing we have to do is figure out who is the parent graph and graph it, and then we can use transformations to figure out what the graph of f of x looks like. So the parent graph is going to be y equals log to the base 1/2 of plain old x. So remember, the base is 1/2, and 1/2 lies between 0 and 1. Therefore, this is going to be the decreasing parent graph. So we need to figure out a couple of accurate points on this graph. So I'm going to draw a t-chart. The first point is always when x is 1, because log to any valid base of 1 is always equal to 0. That's one of my key points. Another key point is whatever the base is, we put that in for the x value. So my base is 1/2. So I have to figure out log to the base 1/2 of 1/2. And remember, that is one of the basic properties of logs. Log to the base 1/2 of 1/2 is 1. So that's going to give us another key point of 1/2, 1. And then logarithmic functions always have vertical asymptotes. And on the parent graph, the vertical asymptote is always the y-axis, otherwise known as the equation x equals 0. So let's graph our parent graph. So I'm going to graph in the vertical asymptote here, if it will graph in. Here we go. And then I need to graph the point 1, 0, which is right here. And then I need the point 1/2, 1, which looks like it's going to be about there. And I'm going to get my decreasing graph, which is going to start up here approaching the vertical asymptote, come on down this way. Okay, this won't be very pretty, but I'll do the best I can. And I'm drawing it in as a dotted line because it is my parent graph. So there is my decreasing parent graph. So now I'm ready to tackle my function f of x. F of x is log to the base 1/2 of x plus 3 quantity minus 2. So the x plus 3, what is that going to do to my graph? It's inside the function, so it's going to be a horizontal effect. And when you add and subtract numbers, it shifts it. So it's a horizontal shift. And since it's a plus 3, remember horizontal always does the opposite of what you think. It's going to shift it to the left 3. Then we have to look at this minus 2. It's outside the function, so it's definitely going to be a vertical effect. And we're subtracting 2, so that means I'm going to shift it down 2, because vertical does exactly what you think. Now, I have two effects here, a horizontal shift and a vertical shift. I need to make sure I do it in the correct order. We always do the horizontal shifts first, and we do the vertical shifts last. Now, if this was a transformation involving reflections and stretches and shrinkages, I would do it in 2 steps. But if this is just 2 shifts, that's very easy to do in 1 step. So I'm going to move everything left 3 and then down 2 all in 1 step. So the first thing I want to do is take my asymptote. So if I take a point on my asymptote, and I shift it left 3, 1, 2, 3, and then I'm going to shift it down 2, 1, 2. So this is going to be a point on my asymptote. If I take another point on my asymptote, if I shift it left 3 and then down 2, I think you can see that all these points are going to land up on the vertical line x equals -3. That's going to be my vertical asymptote. And now all I have to do is move these points. So I'm going to take the first point, 1, 0, which is right here, and I'm going to move it left 1, 2, 3, and then down 1, 2. So there is a point on my graph. Then I'm going to take the point 1/2, 1, and I'm going to move it left 1, 2, 3, and then I'm going to move it down 2, 1, 2. So there's my second point on the graph. And now I'm going to try and draw a line through that. It won't look very pretty, but this is about the best I can do. And you're going to get something that looks like this. Please remember that your graph should never touch or cross your vertical asymptote of x equals -3. So when you draw it, it comes on up, it approaches the asymptote, but it never touches it.